I'm on page 99 of the exercise book. Questions 9 through 11 are based on the information below. A company manufactures a product in the shape of a sphere with a radius of 2.2 inches. What is the approximate surface area in square inches of the product? And they were nice to me. The surface area of a sphere is 4 times pi times the radius squared. So we are going to find the surface area of a sphere when radius is 2.2. And I really should have written that. You don't have to use this notation. I just want you to know that even when it looks scary like that, it isn't. It's just a way of writing in shorthand so you don't have to copy all this down. So you have 4 times pi times radius, that's 2.2, to the second power. Now really, it's the radius to the second power that I need to do first. So let's do 2.2 to the second power. That's the first step. 2.2 times 2.2 is 4.84. And then bring all this other stuff down and multiply it. Times pi times 4 is 60.7904. And I'm going to go with A. That's the closest to my answer. Not sure what's up with that rounding error. Because 2.2 squared is 484 times pi times 4. Not sure, but that's close enough. Number 9 is A. Number 10. The formula for the surface area of a sphere can be written as the function, where r is radius of the sphere. Which is a correct description of this function? Well, its surface area in terms of the radius is 4 pi r squared. So this is a second degree function. It's quadratic. A says linear. It's not linear. B says linear, not linear. C, D, and E all say quadratic. C says a quadratic in which r can be any real number. D says a quadratic in which r can be any real number greater than 0. And E says a quadratic function in which r must be an integer. So let me just tell you why it's not E. An integer. Let's focus on that word just a minute. That is a number. It's a whole number, basically. Let's just call it that. It cannot be a fraction or a decimal. Well, we just did that equation up there with a radius of 2.2, so I know this can happen. It doesn't have to be an integer. So it's not E. A quadratic where r can be any real number, or a quadratic where it must be greater than 0. Now think about it. If radius if r is 0, you wouldn't have a sphere. There would be nothing there because there would be no radius. So we need something that is larger than 0. D is the answer. You can use any real number. It can be a decimal, a fraction, whatever, but it has to be more than 0, or you wouldn't have a sphere to work with. There would be nothing there. Okay, number 11. The box for the product is a cube with side length 4.5 inches. Which expression shows the amount of packaging in square feet needed to make boxes for 200 of these products, when the surface area for a cube is 6 times the side length squared? So here's the thing that sets off the alarm bells in my head. That's in inches, and this is asking for square feet. So we need to come up with the expression to solve this problem. So the sphere doesn't factor into this. We're just talking about the box to put the product in. And that box looks like this. I always like to see a picture, but I can't draw a sphere. That's like a basketball. But this one I can draw because it's angular. So let's copy that and paste it. So here comes the other piece, and then we just connect the vertices, the corners. I need to do it in a straight line. Okay, so here's my cube. Pretend that's straight. So we have 4.5 inches, 4.5 inches, and 4.5 inches. And the formula says the surface area of a cube, and this is going to be based on the side length, is 6s. So the surface area of a cube, when the side is 4.5, will be 6 times 4.5 to the second power. I lost my square. Okay. So we would find the surface area, but then we have to convert it to square feet because the answer, it wants to know square feet. Now, I happen to know from many years of doing math that 1 square foot is equal to 144 square inches. And let me show you why that's true. I'm going to use a square that is 1 foot by 1 foot. That's not a square. Let's try that again. It really needs to be a square for you to see this. So there's a square. That's close enough. So I'm going to copy that and paste it. So we're building another cube. How many inches are in 1 foot? 1 foot is 12 inches. So a square foot, in other words, a square that's a foot long and a foot wide, is 12 times 12. That's 144 square inches. So I'm going to take my surface area, which is this number right here, 6 times 4.5 to the second power. And how many of those do we need? We need 200 of them. And then we're going to convert that to square feet by dividing it by 144. So the answer I want is B. You don't have to do the math. You just have to explain the math. And that is sometimes a lot harder to do, at least for me. I would much rather do the calculation than have to explain the calculation. Okay. Questions 12 and 13 are based on the information below. 2 cell phone plans are shown below. The functions represent the total monthly cost based on X, which is the number of text messages. So for Plan A, that's called f of X, you can get a flat fee of $30 a month plus 10 cents a text message. And in Plan B, which is called G of X, you can do a flat fee of $45 a month and only pay 5 cents per message. So number 12 says, what is the monthly cost of each plan for 150 text messages? So let me try to zoom in here, and I'll do f of X first. Doesn't matter. 10 cents X. Okay, so we want to know this plan when X is 150. So we have 30 plus 10 cents times 150. So this will be 30 plus 15. Just be sure of that. And so this plan is $45 for 150 messages. So the cost of 150 messages is $45 for Plan A. For Plan B, we're using the function g of x is 45 plus a nickel per text. So when x is 150, we have 45 plus 5 cents times 150. I believe that will be 7.5, but let's make sure. And it is. So $7.50 plus that flat fee of $45. I'm not even taking chances here. $52.50 for this plan at 150 text messages. So Plan A is $45, Plan B is $52.50. So I like answer B. Which statement is true? Under Plan B, the cost of 310 text messages in 1 month will be $61. So let's do g of x, that is Plan B, which is 45 plus a nickel per text. And we want to test that for 310 messages. So that will be $45 plus 310 times a nickel is $15.50. So that total cost is $60.50. So A is a false statement. Plan B is cheaper for 450 text messages in a month. Well, that's g of x, and I'm just going to say 450. So we would have 45 plus a nickel times 450. And I need to conserve space, so I'm going to say 450 times a nickel plus 45 is $67.50. And then we need to do f of x. Sorry, for $4.50. And that was going to be 30 plus a dime per text. So $30 plus 10 cents per text message. So this is 30 plus 45. That is $75. So Plan B is cheaper for 450 text messages. I think that's the one. And if I were taking a test, I would stop right there because we know that one's true. Plan A will always be cheaper than Plan B. That is not true, and I just proved it to you right here. Plan A is more expensive than Plan B. Under Plan A, the cost of 280 messages in 1 month would be $59. So f of x, when x is 280, will be 30 plus 280 times a dime. That'll be 30 plus $28 is $58. So this is a false statement. And Plan A is cheaper for 350 messages than is Plan B. So for Plan A at 350, we would have $30 plus 10 cents times 350. That'll be 30 plus 35, or 65. And then g of x, let's say g of 350, would be 45 plus a nickel times 350. So that would be 45 times, 45 plus 1750 is 6250. So Plan B would be cheaper for 350 messages. So that is a false statement. The answer you want is B, the true one. Now, I do want to show you one thing here, because this is a very common math question. And that is how to find when the two plans are equal. How many messages could you get where it just wouldn't matter what plan you had? And if you need to do that, here's the background. You want to know when f of x and g of x are equal. So f of x is 30 plus a dime per message, and g of x is 45 plus a nickel per message. So we need to solve this equation. And I'm going to move the smaller x value. You can do it either way, but this will avoid negatives. So there's that one. So we're left with 5 cents positive times x. There's the 30. And then on this side is the 45. So then I'll move the 30 and cancel. So I'm left with 5 cents x equals 15. Divide $15 by a nickel, and you will have the number of text messages. So 15 divided by 0.05 is 300. So if you have 300 text messages, it will not matter which plan you have. The plans would be equal at 300 messages. They didn't ask me that, but a lot of math tests do. So I just wanted to remind you of how that's done.